Hi everyone, I just thought I would start trying to help you revision a bit. Going to do a quick example involving some cash flows and discounting them cash flows and accumulating them cash flows. So let's go. So let's come up with some cash flows. So time 0, 1, 2, 3, 4, 5. And by the way, if you hear my dog in the background, he's pretty noisy. He's a pug, so he's always making noise, and you'll hear me talking. So that might mean he might come and try to find me. Right. So got the time. Let's do some cash flows. -1, -5, 2, 2, 2, 2. Okay. Right. So question 1. Find NPV of these cash flows at time equals 0. Question 2, find the accumulated value at time equals 5. Okay. So let's put two columns in: present value, accumulated value. We'll assume an interest rate I equals interest rate. That's an effective interest rate, and then just assume it's an annual one, assuming that these years are annual. Right, okay, so present value. So we're times 0, -1, -5v, 2v squared, 2v cubed, 2v4, 2v5. Line under that, the summation is the net present value. So we've got the present value of each one of these cash flows, add them all together to get the net present value, so the summation is Q1. Right, so that's question 1. I'm not going to compute them. Accumulate value. So now we're accumulating these to time 5. So -1, 1 plus I to the 5, or -1 over V to the 5. -5, 1 plus I to the 4, 2, 1 plus I, 3, 2, 1 plus I squared, 2, 1 plus I, and 2. So sum that, and we get the accumulated value, or the net present value, I suppose it is, at time 5. Q2. Done. Right. Okay, next thing. So next thing to think about, can we use NPV at 0 to find the accumulated value at 5? Well, the answer is yes. The answer is yes. Accumulated value 5 equals NPV of 0, 1 plus I to the 5. Good. Okay. Right. Okay. Let's see if we can use some annuities. So what have we got in these cash flows? Let's have a look here. Where we started. Well, we can't do much with the -1 and -5, but then we've got some 2's there. We've got 4 lots of 2 there. So let's do question 3, present value, net present value, please, using annuities. So NPV equals -1 -5v, and that's plus 2a. So let's have a look. We've got 4 payments, so that's 4 there. And is it advance or arrear? So if we say if we start the annuity at that 2, so we'll say that's advance. But then of course we've got an extra v squared to deal with there. Right. Question 4. What about the accumulated value? T equals 5. So the accumulated value at 5 equals -1, 1 plus I to the 5th, minus 5, 1 plus I to the 4th, can't do much with that, plus 2 Now we're going to use the S function here. So first of all, we've got 4 lots, so we'll put that there. 4. Now, do we use advance or do we use arrear? Now the rationale is you look at the end point of the cash flows to decide, or my method is. So where I see that there's no interest being applied in the last cash flow, we know we're right at the end of the period, so therefore that's the arrear annuity. If you remember from when we learn our formulas for these, using things such as 1 plus I to the 4 plus 1 plus I to the 3, all the way along to 1 plus I, for example. So this one is in arrear for 4 periods. We've got a formula for this. This equals 1 plus I to the 4 minus 1 over I. So we can use that. So hopefully both formulas or both methods for the present value and the accumulated value equal each other. I haven't computed them, but if you want to, please do, but it should be fine, but you never know. So hopefully that's been a useful quick run through of the basics of discounting and accumulating a series of cash flows and using some annuity functions too. Thank you.